All right, folks. In this lesson, what we're going to do is we're going to learn how to graph linear inequalities. Okay? Now, linear inequalities are very peculiar looking, and therefore I'm going to show you why they look like what they look like. Now, you might be thinking, Mr. Ryan, can't you just show us how to do it and then leave everything else alone? I understand that sentiment. I understand why you feel that way. And if that's your level of learning, then by all means, just watch how to do it. But if you are interested in understanding why a linear inequality has a particular graph that looks a certain way, I think that this may help you. So what we're going to do is we're going to start with the linear inequality y is less than 2x minus 3. Now, what I want to show you is I hope you notice that this is in y equals mx plus b form. It's in the form of a line, slope-intercept form. And slope-intercept form is probably the easiest way to graph a linear inequality. So you should have an x and a y, and I recommend if the linear inequality you're dealing with is not already in y equals mx plus b form, you should put it in that form first. So that would be step one, is put your inequality into slope-intercept form. That's the first step. Now what we're going to do is, I've used a grid, okay, to create 8 number lines. Okay, so I've got 8 number lines here, and they all have equal distance apart on the numbers. Okay, I didn't mark them because I'm going to draw on them. It's going to be harder to see it if I have the numbers. But I have marked where 0 is. So here's 0, 1, 2, 3, 4, 5, negative 1, etc. Okay? Note that I've put all of the zeros on top of each other. And if you're producing this in your notes, I recommend you use graph paper. And make sure that you put all of these lines one unit distance vertically, because what we're ultimately going to do is we're going to impose a grid on this so that you can see why the linear inequality has a graph that looks like what it looks like. And we're going to use y is less than 2x minus 3 to do that. And so what I'm going to do is this, is I'm going to fill in for y. Okay, this is not solvable. Remember that inequalities and equations can only be solved. If you only have one of them, you can only have one variable. That's just a universal rule of math, that for every one variable, you need one equation or inequality to have a solution. And in this particular case, we only have one inequality, but we have 2 variables. Therefore, we have no solution. We have an infinite number of solutions. Although technically, it's an inequality, so we have an infinite number of solutions anyways, but never mind that. So what I'm going to do is I'm going to fill in for one of the variables. I'm going to put a number where the y is, and then solve for x, and then graph the inequality on the number line. Okay, that's my goal. That's what I'm going to do here, which is something you already know how to do. You learned that a few lessons ago. So what I'm going to do is I'm going to call this one 3. So this one is going to be 3 is less than 2x minus 3. This one's going to be 2. So 2 is less than 2x minus 3. This one's going to be 1 is less than 2x minus 3. This one's going to be 0 is less than 2x minus 3. Negative 1 is less than 2x minus 3. Negative 2 is less than 2x minus 3. Negative 3 is less than 2x minus 3, and negative 4 is less than 2x minus 3. Okay? Now we're going to solve all 8 of them. I know it's a bit of work, so what I'm going to do is I'm going to go ahead and fast forward here and solve all of them. Okay? So here we're going to add 3 to both sides. So we're going to have 6 is less than 2x. Then we're going to divide by 2 on both sides, and we get 3 is less than x. Or remember, we can flip this around and it becomes x is greater than 3. Okay, so the solution for this one is x is greater than 3. And so we'll go to 1, 2, 3. We'll do an open circle, and then we will draw a solid arrow over here, and there is our solution. X is greater than 3. Now if we do this one, add 3 to both sides, this becomes a 5, divide by 2, and we get x is greater than 5 over 2. That's 2.5, right? So that's going to be 2.5. So that's going to be right here. And here's our solution. All those numbers, right? Okay, good. Now for this one, add 3 to both sides. This becomes a 4. Divide by 2. That means x is greater than 2. Okay? And so we'll go 1, 2. We'll open circle. Okay, we have just solved 8 independent linear inequalities. We got 8 separate solutions, and we graphed all 8 of those separate solutions. You can see here, because they all say less than, the solution says greater than, right? Now, you might be wondering, why did we flip it around? Well, remember, when the x is on the other side, remember how I like to give the answer explicitly, not implicitly, okay? And so, I want to be in the active voice, not the passive voice. I don't want to say that 3 is less than x. I want to say that x is greater than 3. That's why I flipped it around. So x is greater than 3, okay? And so, I have all these solutions. They're all greater than, and therefore the arrow is on the right side going to greater than. Because it doesn't say or equal to, I have an open circle, right? And they're all 8 independent. But here's the interesting thing. Because they're all actually the exact same, we have the same expression on the right side, but a different number on the left, that means that they're all related to each other in a linear way. And here's what I want you to notice. I'm hoping you noticed this already. Isn't it interesting that as we go up in number from -4 to -3, -2, -1, 0 to 1 to 2 to 3, okay? Isn't it interesting that all of our circles are sort of lined up on a diagonal? See this? If I take this ruler right here and I place it here, isn't it interesting that all of our circles are lined up on a diagonal? In fact, we could impose a line in here sort of connecting all of these open circles. Now, the fact that they're open circles means that these numbers are not included in the solution, right? We already learned that. So here, the answer is 2. 2 is not included in the solution, because if we plug a 2 in, 2 times 2 is 4 minus 3, that's 1. 1 is not less than 1, so this number would have to be larger than 2. That's why we have the open circle, right? Well, now, if you can see here, this is a straight line that starts off all of the solutions, and what I want to show you is that this line, with all of the shading on this side. Now, you may think that all the shading is on the right side, but the truth of the matter is that all of this shading is actually below the line. And I'm going to show you that when we do a few examples. This, what you're seeing here, is the graphical solution of y is less than 2x minus 3. This is a linear inequality, and this is the graph of it if I now give you a grid. If I now give you a coordinate plane, you can now see, I'm going to go ahead and erase the rest of this stuff, all the work that we did. There we go. And you can see that this grid right here, where we set y equal to 0 is the x-axis. right? And the x-axis is where y is equal to 0. And look, where all these zeros are, that's the y-axis where x is equal to 0. And over here is where x is equal to 2, x is equal to 2.5, and x is equal to 3. And what we have here is the graph of a line that is basically y equals 2x minus 3. See, look, 2x minus 3 has a y-intercept of negative 3. Okay, well, let's go to the y-axis. Here's 0. And let's go down. Negative 1, negative 2, negative 3. Look, it's intersecting the y-axis at negative 3. And it has a slope of 2. If we start here and go up 2 over 1, there's the line. Up 2 over 1, up 2 over 1. This line is the line y equals 2x minus 3. Well, now let's talk about all this shading. Well, there are an infinite number of points between all these, right? And so what we really have is all along here we have a whole bunch of open circles with shaded arrows that go off to the right. An infinite number of them. And what that would ultimately do is this. It would ultimately shade in this entire region on the underside of the curve. I know what you're thinking. You're thinking it's not the underside of the line, it's the right side of the line. You can't think that way. You have to change that thinking. The shading is not to the right, the shading is below the line. Why is the shading below the line? Because the symbol is a less than symbol. Because it's y is less than 2x minus 3. And since this is 2x minus 3, the entire region below 2x minus 3 will be shaded in. And that's ultimately what's going to happen. Okay? Now this is the theory, this is the understanding, the explanation behind why the graphs look the way they look. Now we're going to see how to do it. All right, I need to show you one thing before we actually start graphing these inequalities. The first step of graphing any inequality is always drawing a line based on the slope-intercept form, y equals mx plus b. The thing is that sometimes you're going to draw the line as a solid line, and sometimes you're going to draw the line as a dashed line. And I need you to understand when to do each of those things. Now, you may already know the answer to this. Maybe you've seen this before. But just in case you don't, I want you to understand. If your linear inequality has a less than or equal to symbol, or it has a greater than or equal to symbol. If it has the or equal to, the line that you draw is going to be a solid line. Okay? And that is the same thing as a closed circle. Because what you basically have is all the way up the line you have a whole bunch of closed circles. Okay? The dashed line is going to be is kind of like open circles. Okay? So you'll do a dashed line when the symbol is less than or the symbol is greater than, and it does not have the or equal to. So if your linear inequality does not have the or equal to, then when you draw the line on the graph, you're going to draw a dashed line. So solid line if you have the or equal to, dashed line if you do not have the or equal to. Okay? And now let's go ahead and draw some of these graphs. All right, so let's try our first example. Here's the first one we're going to do. We've got y is greater than or equal to x minus 4. Okay, so this is the linear inequality that we are going to graph. Okay, so step one, the very first thing you want to do is, in case it's not, now this one is, the very first thing you want to do is put or transform, let's say, transform into slope-intercept form. Transform into slope-intercept form. which it is. This one is in slope-intercept form. And our slope is 1, our y-intercept is -4. Step 2, plot the line but do not draw the line. So what we want to do is we just want to put in a bunch of dots, okay, along this line. So how are we going to graph? If it was as if it was an equality, okay? So if this was y equals x minus 4, then from the origin we go down to -4, 1, 2, 3, 4. We would plot our y-intercept, right? And now the slope is 1, so that's up 1 over 1, put a dot, up 1 over 1, put a dot, up 1 over 1, put a dot, okay? Put a dot, put a dot, put a dot. Okay, we can even go backwards here, put a dot, okay? All right, then step 3 is draw the straight line. The straight line, okay? Now, if it is less than or that it's a greater than symbol, then you want to do a dashed line. But if it's a less than or equal to, or it's a greater than or equal to, then you want to do a solid line, okay? Now, this is an or equal to, this is greater than or equal to, so we're going to draw a solid line through here. So I'm going to grab a ruler, or straight edge, whatever you want to call it. Down here, I'm going to line these up, all right? And I'm going to draw a straight line, a solid line, all the way through these points. There we go. There we go. This is step 3. Okay, so up till now, you've already done this. Okay, you've done this a couple lessons ago where you were just graphing linear equations, okay? But now comes in the shading, okay? What we want to do is all of our solutions, because there are a lot of solutions that will satisfy this line, all of the solutions have to be coordinates, x and y coordinates that will make this true. And what we have to do is we have to either shade above this line or below this line. And so here's what I do, okay? I'm going to say shade the region above or below the line. Above or below the line, okay? And here's how you're going to determine. If the symbol is greater than or equal to, you're going to do above. If it's less than or equal to, that's where you're going to go below. See, this says greater than. Greater than means up, okay? Things that are higher. Greater is another way of saying higher, and less than is another way of saying lower. So, with a greater than symbol, I'm going to use up arrows, and with less than, I'm going to use down arrows. And so what I'm going to do is I'm going to go to this line, and since this is greater than, that's up arrows. All along the line, I'm going to put up arrows. See this? Up arrow, up arrow, up arrow, up arrow, up arrow. And that's where I'm going to shade. And so now I know that this entire region is the solution area. Now, you may have had a middle school teacher, you may have learned this in middle school, and you had a middle school teacher that insisted that you perfectly shade using the edge of a pencil. And it had to be consistent the whole way. I'm not like that. To me, this is sufficient shading. I'm just doing this. So I'm shading the solution region, and that means everything over here is a correct solution. Okay? Now, there's another way to determine where you're going to shade, and that's called the sample point. Okay? See, the idea is, let me show you something. The fact, this shaded region, what it represents, we know that the entire solution, every point over here is a solution, and every point over here is not a solution. So if you were to take any point up here and plug it in, it would make it true. So for example, how about the point 1, 3, right here? It's in the solution region, right? So if we put a 1 in for x and a 3 in for y, this should be true. So if I put a 3 here, 3 is greater than 1 minus 4. Okay, well what's 1 minus 4? 1 minus 4 is negative 3. Is 3 greater than or equal to negative 3? Yes. So this point is in the solution region. On the other hand, if I take a point that's outside of the solution region, like 1, 2, 3, 4, 5, and negative 1, so we'll do 5 and negative 1. 5 for x, negative 1 for y. Okay. I'll put a negative 1 in for y, greater than or equal to a 5 in for x, 5 minus 4. Well, 5 minus 4 is 1. Negative 1 greater than or equal to 1. Is it true that negative 1 is greater than or equal to 1? No, this is false. And because this is false, we know that the region where this point is not the solution region. And so what this now brings is what I call, or what I'm sure many people call, the sample point test for the solution region. And what a lot of people use is they use the origin. They just go straight to 0, 0. Why? Because 0, 0 is easy to plug in. If we put in a 0 for x and a 0 for y, we get 0 is greater than or equal to 0 minus 4. And what is 0 minus 4? Well, that's negative 4. Is 0 greater than or equal to negative 4? It sure is, and that means that the origin is in the solution region, and therefore, which is on the upper side of the curve, which means this is the side that we would shade. Okay? All right, let's do a few more examples. All right, here's an example. We've got y is less than negative x minus 2. Why don't you take a piece of graph paper, draw a coordinate plane, okay, and try it for yourself, okay? Pause the video and try it for yourself. Okay, so now let's see how well you did. So the first thing we're going to do, we're going to transform into slope-intercept form. It's already in slope-intercept form, okay? So now we're going to plot the line, but we're not going to draw the line. Okay, so if this was y equals negative x minus 2, the way we would plot that is we would start at the y-intercept of negative 2. So we go to the origin, go down to negative 2 and put a dot. The slope here is negative 1. So we're going to go down 1 over 1, down 1 over 1, down 1 over 1. We can also go up 1, back 1, up 1, back 1, up 1, back 1. Okay? All right, and now we're going to draw a straight line. Now we have to determine, is it going to be a solid line or a dashed line? Okay, well, up here we have less than or equal, or excuse me, not or equal to, it just says less than. Therefore, this is going to be a dashed line. So we're going to get our straight edge. So maybe you have a ruler or something like that. It'll be helpful. And we're going to line it up here. Line it up as best we can. And now we're going to draw a dashed line. And now all we have left to do is shade the correct region. Now, let's do the sample point, shall we? Okay, and I like 0, 0. So we'll select 0, 0 and we'll plug it in here. Put in a 0 for y is less than negative 0 minus 2. Well, there's no such thing as negative 0. 0 is neither negative nor positive, so we're just going to make it 0, 0 minus 2. And 0 minus 2 is negative 2, so we have 0 is less than negative 2. Well, is 0 less than negative 2? No. 0 is greater than negative 2. That means that this is false. And because this is false, we will not include the origin in the shaded region. Well, the origin is over here, above the line, and therefore we're going to shade the region below the line. So we're going to shade this region right here, and that is our solution region. And so this, I know you're like, well, that looks really basic. It is very basic. This is our solution to this linear inequality. Okay? All right, well, what if we did the other technique for shading? What if we didn't do the sample point? Well, the other way is to do the up arrows and the down arrows, right? Well, this says less than, right? Well, for a less than symbol, we're going to use downward arrows. So we're going to go all along the line and put downward arrows. Now, note, they're not diagonal. They are vertical, perfectly vertical arrows pointing downward. Well, it's kind of obvious, isn't it? You don't have to put that many of them. You only need a couple of them, right? Let's say I only put one here and one down here, okay? And both of these, they're showing that this is the region I should be shading. And so I'm just going to shade this region right here. Sometimes I just write S.R for solution region down here, and I didn't write it up here. That makes this the solution region. Now, that means every single point down here should make this true. So let's pick one down here and see if it's true. How about this one right here? This point is -1 and -3. So we're going to put -3 in for y is less than -1 minus 2. Well, -1, that's 1. So we've got -3 is less than 1 minus 2, and 1 minus 2 is -1. -3 is less than -1. Is -3 less than -1? It sure is. Therefore, true. Therefore, this point is in the correct place in the solution region. Okay? Let's try another example, but I'm going to give you one where you have to do step 1. All right, here's our next example. All right, we got 2x minus 3y is less than -3. Now, this is in ABC form of the line. Okay, we want it in slope-intercept form of the line. And so we want to isolate y. We want to solve for y. All right, basically what we're doing here is a literal equation. We're trying to solve for everything in terms of y. So the first thing I'm going to do is I'm going to subtract 2x from both sides. Subtract 2x. It's going to cancel over here. It's going to leave me with -3y is less than -2x minus 3. Okay? And now, to isolate y, to get y by itself, I'm going to divide by -3. But I have to divide I can either divide both sides by -3. Another way of doing that is to divide each item by -3. Okay? All right. Over here, it's going to cancel the -3, and so we're going to bring down the y. Now, we need to be careful about something here, because we just divided by a negative number. Remember that whenever you multiply or divide by a negative number, not when you result in a negative number, no. Whenever you actively multiply or divide by a negative number, you have to switch the inequality symbol. So this less than symbol now has to become greater than, and now -2 divided by -3, well, a negative divided by a negative, that's a positive, right? So this is 2/3, and then we have the x, and then -3 divided by -3, that's +1, so that's +1. And so our linear inequality is y is greater than 2/3 x plus 1. Now we can graph it. Okay, so we've got our y is greater than 2/3 x plus 1. So the next step is to plot the line, but don't draw it. Okay, so we're going to a y-intercept of +1. So here's the origin up to +1. And we have a slope of 2/3. So that's up 2 over 3. Up 2 over 3. Up 2 over 3. I can even go down 2 and back 3. Okay? And so now I'm going to draw a solid line or a dashed line based on whether there is an or equal to in it, right? Well, there's no or equal to. Okay, so we're going to do a dashed line. So I'm going to grab a straight edge, grab my ruler here, line it up. I'm going to do a dashed line here. All right. Here we go. Dashed line. All right, and now all we have to do is shade the region above or below. Okay? Well, this says greater than, And so that means above, right? Well, here's the region above the line. If I did some upward arrows, you would see that this is the region, this is below, this is above. And therefore this is the solution region. And I'm shading the solution region. And we can clearly see that all of the coordinates that are above this line, but not including the line, if I were to plug in these numbers here, this is the point 3 and 2. If I plug in 3 and 2, it will not solve. So if I put a 3 here and a 2 here, 3 times 2/3 is 2, plus 1 is 3. If I put a 3 here, I get 3 is greater than 3. Well, 3 is not greater than 3, and therefore, on the line is not a solution. I could also use the sample point, 0, 0. Okay, if I put a 0 here, 0 is greater than, 0 times 2/3 is 0, plus 1. 0 plus 1 is 1. Is 0 greater than 1? No. Therefore, the origin, 0, 0, is not in the solution region, so you would not shade the region that includes 0, 0. You would shade the other region. Okay? All right. I think we should do at least one more example, and you should feel kind of comfortable. All right. Here's our last example. Let's say that we have y is less than or equal to 4x minus 3. We are going to, it's already in slope-intercept form. So we're going to go straight to step 2, which is plot the line. We want to go to the y-intercept, which is negative 3. So we're going to go down 1, 2, 3, put a dot. We got a slope of 4. That means we got to go up 1, 2, 3, 4, and over 1. Then maybe again 1, 2, 3, 4, and over 1. Okay. Now, are we going to draw a dashed line or a solid line? Okay. Well, we've got the or equal to, and that means that we're going to do a solid line. So we're going to grab our straight edge here. We're going to line up these points. There we go. Line them up. And draw our line straight through. Okay, and I could draw more down here if I wanted to, but that's good enough for now. And now I have to determine whether I'm going to shade above or below. Now these steep slopes, they will trick you. Because with a slope that's really steep, or even if it was a negative slope, maybe we'll do one more example with a negative slope. These steep slopes will trick you because it's hard to see which side is above and which side is below. And this is one of the reasons why I really like the arrows, or I like the sample point, okay? So what I'll do is, if I'm going to use the arrows, I will go to an actual point on the graph, or on the line, right? And from there, along that vertical, I will draw my arrow. So this is a less than, so I'm doing a down arrow. From here, I will draw a downward arrow, and that downward arrow tells me where I should be shading. Should I be shading over here? No, the arrow is not over here. If we were to say left or right, this would be left, but it's not left, it's up. This is down. So I'm going to shade where this arrow is, and then I'm going to keep shading. And now you can see I have my solution region right there. It's over on this side of the line, okay? And this is my graphical solution for this. Now, of course, I can also take the sample point, 0, 0. I can put a 0 in for y, less than or equal to 4 times 0 minus 3. 4 times 0 is 0. 0 minus 3 is negative 3. Is 0 less than or equal to negative 3? No, it's larger than negative 3. Therefore, 0, 0 is not in the solution set, and I'm going to shade over here on the right, okay? All right, let's do one more with a steep negative slope. All right, so this one right here, we've got y is less than or equal to negative 9 over 2x plus 5. Okay, we got a couple things going on here. It's a negative slope. It's a fraction slope, which you should be just fine with. And negative 9 over 2 is pretty steep. Okay, it's even steeper than the one we just did. So we've got it in slope-intercept form. Now we're going to plot the line. Okay, so we're going to go to positive 5, 1, 2, 3, 4, 5. And then we're going to go down 9 and over 2. Now another way we could do this is we could go up 9 and backwards 2. This is the change in x. So we could go back 2 and up 9, But if we go back 2, we don't have room to go up 9. So we're going to go down 9 and over 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, over 2 right here. Now this may be a little long, a little far of a distance for my yardstick here, but we'll see how it goes. Then it says draw the straight line. We're going to make it dashed or solid based on whether there is an or equal to. This one has an or equal to, so we're going to make it a solid line. And so we're going to connect from here. Oh, we can make it. Look at that. We're going to connect from here to here with a solid line. Now what I'm going to do is I'm going to use a different color just to change things up a little bit. Okay. And draw a nice pretty purple in there. There's our solid line. And now our last step is to shade. Are we going to shade above or below? Well, this one is a less than, so we're going to shade below, okay? And so that means we can do downward arrows. So pick any point on the line, maybe right here, and draw a vertical line downward. That arrow is in the solution region. So we're going to shade over here below. We're going to shade this side of the line, below the line, okay? Now, remember, we can also do the sample point. We can take the point 0, 0. Now, you don't have to do 0, 0. You can take any point as the sample point. We could take the point 2, 2 over here, and it'll show that it is not true, and therefore we would shade the other side. The only reason we keep using 0, 0 is because it's easy, okay? So, put a 0 here and a 0 here. 0 is less than or equal to negative 9 over 2 times 0 plus 5. Negative 9 over 2 times 0 is 0. So we have 0 is less than or equal to 0 plus 5. Well, 0 plus 5 is 5, so 0 less than or equal to 5. Is 0 less than or equal to 5? Yes, it's less than 5. Therefore, 0, 0 is in the solution region, and that means that we would then shade this side over here. This is the solution region. Okay? All right. That's all I have for you. You got to do lots of examples. I think I gave you about 10 or 12 of these on paper, and then there are going to be a bunch of them that are in the practice quiz. And once you fully understand this, we'll then be able to move on to our another thing that we're going to learn with graphing inequalities. We're going to do systems of linear inequalities.